Question 1. Question 1, the first thing you need to do is make sure you've had a look at the graph and you've looked at however many ways you can describe and explain everything you can see before you start writing. It's okay to make notes all over your graph and write on it, colour it in, highlight stuff, just so you know what you're going to write about. So the first thing you need to do is describe how the graph changes as the temperature of your enzymes increases. So the first point to note is that the activity of both enzymes rises to a peak and then falls. That's true for A and B. And you can see, starting from the blue circle, both lines go up and then down. So first thing to note is this area shown with the red arrows. And the activity of A is steeper than B, so that's showing that it's getting more active more quickly than B. If you look, this gradient for A is steeper than B. It gets to a point where they're both rising pretty much the same speed, and before they get to their optimum temperature, as the temperature increases, the activity of the enzyme increases. This is due to collision theory, so the faster the enzymes are colliding with the substrate, the more active they will be as they get warmer, up to a point where there's a peak. So the peak for green, the peak for pink are the two peaks for A and B. And at this point you should note that the maximum activity for A is at a lower temperature than for B. So A peaks at the green point, 14 degrees C, and B peaks at 17. So it's a difference in temperature for their optimum temperature. There's also a difference to note here, is that the maximum activity for A is lower than B. So A doesn't get as active as B, shown by these two different arrows here. After the optimum temperature, activity for both enzymes falls because the enzymes are being denatured by heat. They get less active and eventually stop working. And this is due to the active site becoming unable to fit the substrate in. So at a point where there's no activity, the active site is totally inactive and therefore nothing happens.